New parts which were introduced for this project include from left to right the 4011 IC, the 4017 IC, the 4510 IC, and the 4511 IC. At rest, the NAND gate oscillator sends out a high to the rest of the circuit. This is true because here there is no path to ground, so a high is presented on these two pins, which puts a low here. Since there's at least one low on these two pins, a high is presented here. Since a high is here, a low is here. Since a low is here, a high is here, and that high is presented to the rest of the circuit. When S1 is closed, a path to ground is presented here. This presents two lows on these two pins, which presents a high on this side. This high travels to ground here and begins charging this capacitor. This capacitor discharges but can't discharge this way because of the diode, so it begins discharging into this NAND gate. When this capacitor stops discharging, the entire circuit stops functioning. C2 now begins to discharge the charge which it had built up before S1 was pressed into the input A of NAND 2, which creates a low here, which creates a high here, which creates a low that goes out to the rest of the circuit. Once C2 has discharged past the point of providing a high to input A, it will now present a low to input A. This presents a high here, which starts charging C2, and also creates a low here, which creates a high here, which sends a high out to the rest of the circuit. Once C2 has charged enough, this entire process will repeat again. This process repeating will create a square wave pattern, which will control the counting aspect which will be present in the rest of the circuit. The sole purpose of the 4017 IC is to use the divide by 10 output to lengthen the frequency of the clock signal, as can be seen by the comparison between this clock signal and this clock signal. The clock signal is inputted here. This IC outputs an array of highs and lows, which represents a binary number. This binary number will change based on the amount of pulses which the clock signal has created. For example, since there has only been one pulse in this scenario, the number displayed will be 0001. But if two pulses had occurred, the number would be 0010. In order for the average person to understand what number is meant to be displayed, this binary number must now be converted into decimal. This is done by inputting the arrays of highs and lows which make up the binary number 0001 into a 4511 IC. This creates an output with highs on the E and F pins and lows on every other pin, which result in the LEDs which signify the decimal number 1 being lit up. This display will keep cycling through decimal numbers for each rising edge which it receives.